Okay, today is the 26th. Okay, so we are looking at problem 37 on page 505. And here's the function, f of t. They say 100,000 divided by 1 plus 5,000 times e to negative t. So this is number of people. T is number of weeks. How many people became ill with the flu when the epidemic began? Are you okay?
Yeah, I just around the 8 weeks. I get explained.
Okay. So what does that mean? I'm asked to find how many people were ill at the beginning of the epidemic. What am I asked to do? Exactly. So I have to find f of 0. So let's do this together. How much is e raised to 0? Or any number raised to 0 as long as the number is not 0? 1. So e raised to 0 will be 1. So how much is 1 times 5,000? How much is 5,000 plus 1? So now I have to divide 100,000 by 5,001. What do I get? And I cannot have 0.3 people. So what do I get? 100,000 divided by 5,001.
Yeah.
Okay, 19.
I just wanted down so
Yes,
okay.
yes, I cannot round up. If I have 19.8, I still don't have 20. Good, very good. Part B, we're asked to find how many people were ill by the end of the 4th week. What am I asked to do now? Okay, I recommend putting the function in the graphing calculator. So in y equals, please, clear. Please be very careful, the numerator has only one number. Otherwise, I would put everything in parentheses for the numerator. Divided by, in parentheses, 1 plus 5,000 times, or not, second, and e is right here on the natural log. And this is negative x. I prefer putting the power in parentheses because I'm old-fashioned. The newer calculators probably don't need that, but I want to be on the safe side. So the 100,000 at the top and 1 plus 5,000 times e to negative t. I don't have t, I have x in the calculator. So I just press, I go now to second and table, and I put in the numbers I need. So I had 0 initially, and I had 19.9996 people, which I cannot round up when it comes to people. And then I put in 4 weeks, and I get, if you want to go back and see as many digits as you want, so 1,080 people at the end of the 4th week. So now for part C. In part C, they're asking us, what is the limiting size of the population that becomes ill? What does that mean? What am I asked to determine? So I was asked initially, then I was asked 4 weeks later, and then I'm asked, what happens when? It says, what is the limiting size of the population that becomes ill? What is the maximum possible number of people that can become ill? Say it again. Yes. I know. There are 19 people initially, and 4 weeks later there are 1,080 people that got sick, who got sick. So that's what I'm asking. I was asked to determine how many people in the long run. If this epidemic never goes away, what is the maximum number of people who can become ill? So what am I asked really to determine? So one more time, I was asked initially, I was asked 4 weeks later. What am I really asked now? It's really about the end behavior of the function. Where does this function go as time goes by? Does it go that way? Does it go this way? Does it approach a number? So I'm really asked to determine the end behavior. So what do I make t become? I looked at 0, I looked at 4. What else should I look at? As time goes by. Bigger and bigger as time goes by, right? Limiting size. What can happen 100 weeks from now? Okay? The limiting size. So I will say what happens in 20 weeks. Let's see what happens in 20 weeks. I'm sorry, I have to go to the X first. So what happens in 20 weeks? Look what happens in 20 weeks. 99,998. Okay, let's see what happens in 100 weeks. Let's see what happens in 200 weeks. Let's see what happens in 500 weeks. What is the limiting size of the population that can become ill?
100,000.
Not more. That's the whole village or city. It cannot have more than 100,000. So what is the horizontal asymptote then? 100,000. Y equals 100,000. So max 100,000. And yes, Brittany, you had something. You're right. It's important to know how many people are in that particular area or village or city or town. So let's discuss this for one more moment because I have many other things that I'd like to go and discuss. So let's start here. As t approaches infinity, negative t approaches, multiply both sides by -1, negative t approaches, negative infinity. So now I have e to negative infinity. Anything to a negative power is nothing else but, what does it represent? A to -3. What is that? Exactly, 1 over a to the third. So how should I rewrite this? Good. How much is 3 to infinity? This is 3 roughly. How big is this number?
0.
Huge. This is huge. So 1 over infinity, yes, it approaches 0. So it appears that this will approach 0. How much is 0 times 5,000? How much is 0 plus 1? How much is 100,000 divided by 1? And that's why it approaches 100,000 as t approaches infinity, which we cannot really say about time. But as t increases without bound. Any questions here?
So is it always the numerator?
It depends on the function. I can't say. Yeah, I can't say. I have to look at the function. Okay, very good. I would like to look at another problem with half-life. We did one last time at the end of the class. I also would like to look at problem 36 and also another problem with half-life. Okay, so let's start with 36. The growth model, A, but it should correctly be A of t. I don't like that because they don't specify the variable. Is 112.5 times E to 0.012 t. This is the given model. Describes Mexico's population, A, in millions, t years after 2010. T years after 2010. What does that immediately tell us? That t equals such and such represents 2010. What does that represent? T equals 0 represents 2010. Perfect. First question. What is Mexico's growth rate? What is Mexico's growth rate? Say it again. If you move the decimal point 2 to, we really hope that it's not the case with 12%. It will be huge. Yes. So R or K, in some books you'll find it as R, in some book is 1.2%. Okay. How long will it take Mexico to double its population? B. Find T that doubles the population. Okay. So what is the initial population? Because I have to identify the initial population, and then I'll figure out how long it needs to double.
T to 0, right?
Yes, exactly. So let's find A of 0, which is the initial population. Perfect. So let's do this again together. 0.012 times 0 is 0. E to 0 is, and 1 times this is, right. So that is nothing else but 112.5 million. This is the initial population. Now we are asked to find how long it takes, find T, for the population to become, A of T, to become how much? 225 million. Excellent. So now please tell me what to write. I am told now the population is 225 million. The initial one was 112.5 million. Find how long it takes the population to double. What will you tell me to write? I'm ready.
225 equals 112.5 feet to the 0.012.
Excellent.
And you would divide by
We will,
112.5.
yes, and I know what I get. What do I get when I divide both sides by 112? What do I get on the left-hand side?
2.
Of course. E to 0.012 t. Now, this is what type of equation? We call it exponential. And you're right. So the only thing I can do to bring down the power, apply natural log to both sides. Excellent. So the left-hand side is natural log 2. And the right-hand side now, I bring that number in front as a factor, and it will multiply natural log e, which is 1. So then I have 0.012 t. And from here, I get t. What should I do to both sides to get t?
Divided by 0.0.
I cannot do this by hand. I have to put in the calculator. So natural log 2. And divide that by 0.012. And I get roughly, approximately, t equals 58 years. Any questions on this problem?
Are you gonna let us choose some problems after?
Oh yes, I want to answer your questions first. Of course, yes. I'm sorry, I forgot. I forgot.
Around. I just had
Of
a
course.
question, like on number
Yes.
69 on page 477.
Okay, let's take a look.
I
69.
just don't understand. I kind of figured it out, but I'm just.
Excellent. So in this problem, we're asked to use properties of logs to condense each log expression. Okay. Now, if you remember, we have 3 properties. We don't. Log functions have 3 properties. Log applied to a product, log applied to a ratio, a log applied to a power. Now, in this situation, I see that two logs have positive in front and two logs have negative in front. The logs that have a negative sign in front, their quantities, these,
So you
the
can put a
7,
negative sign and then put it in parentheses?
you could. That's another way.
Oh.
So if they have negative in front, these quantities must come from the denominator of the expression. If they have positive in front, these two quantities must come from the numerator of the expression. So this is nothing else but log of x times x squared minus 1 over 7 times x plus 1.
So what I did was
You factored out negative 1.
I factored out the x plus 1. So
You can, oh yeah, right here. No. So is this first step understood?
yes.
Okay, yes. Now I have.
Didn't understand.
So now I do have to, I just was waiting for everyone to see it. Yes, I have to factor the numerator into x plus 1, x minus 1. And yes, I will simplify an x plus 1. And yes, the final simplified form is x minus 1 over 7.
Okay, so I got that, but what I don't understand is how you can, cancel out the x plus 1s. Like if it's a log of 7 times 5, or of like, why can't you just do 7 times 5, a log of 7 times 5, or a log of x over x squared over x.
So let me write down what you're saying because I'm not sure. So you said how?
I just don't understand. Within the log, how can you cancel stuff out and do arithmetic inside the log?
Because the log is not there right now. It's an expression that I apply log to where I simplify. I'm not simplifying log. I have an expression that
it's log of 7 times 8. I know you would do log of 7
plus log of 8.
So why can't you just do log of 7 times 8? Why
Very
can't
good
you
question.
do 7 times 8. That's
Okay.
what my main
Okay,
concern was.
here it is. Good question. So log of 8 minus log of 2 minus log of 4. Okay? So is this the same with log of 8 divided by 2 times 4? Yes, of course, because it's minus in front. So these two have to go to the denominator. So this is log of 8 over 8, which is log of 1, which is 0. Now let's start from the beginning. We can plug in these in the calculator, and I guarantee you will still get the same thing. So I simplified the expression that I apply log to. I didn't simplify the log. So after I condense all this into this equation, into this expression, I am allowed to simplify inside of log. And the answer will be the same. So you can plug these in, and let's do it. Otherwise, math makes no sense, right? So I'm using the properties that log exhibits or enjoys, if you want, and I have to get the same answer. So if I have log 8 in parentheses minus log 4 parentheses minus log 2 parentheses, when I click enter, I should get 0. If I don't get 0, something is wrong. So now when I go back to my calculation, once I apply the properties, which means whenever the log has minus in front, the expressions log is applied to go to the denominator. I see 8 divided by 8. I see 1. I can simplify that I'm allowed to, and I know the log of 1 is 0. Is this better?
Yes.
So therefore,
I always just have one question real
yes.
quick. Do you have to do that? Do you have to to simplify like that?
Yes.
Or,
yes.
okay.
Yes, I have to simplify. Like I have to simplify 8 by 8. So I'm not going to tell you the answer is log 8 over 2 times 4. I'm going to say the answer is 0. It has to be fully simplified. Therefore, you will factor the numerator into these two. You will simplify the factor because you are allowed to simplify factors, and this gives you the simplified form of that. Is that clear now?
Yeah.
Okay, very good. Perfect question. Anything else? Please forgive me. I simply forgot to ask you if you have questions. Sorry about that. Any questions? Anything? If you
I have one.
yes.
I don't have it up.
Can I do something else till you find it? I will answer all your questions today. Okay, so I'd like to look at problem 30 on page 505. The reason I started with 4.5 is because I didn't feel that I did enough word problems. So that's why I wanted to start with
Yeah,
this.
I haven't done any of the 4. I was up last night really late doing 4.3 and 4.4, so I could.
Right. That's why we're starting from the end. Okay. The half-life of aspirin in your bloodstream is 12 hours. Okay. How long will it take for the aspirin to decay to 70% of the original dosage? The model is given to us. So we have A of t equals A0 e to kt. I prefer, since it's a radioactive decay, I prefer to present the negative in there. Your book does not do that. The growth rate can be considered as being negative, so that's what they do. So they consider this sign in front to be positive. That's fine too. It will work either way. Okay, so I know that half-life is 12 hours. What does that mean? It means that if I have 10 milligrams now, assuming I take 10 milligrams of aspirin, what will happen 12 hours later? I will have 5 milligrams. What will happen 12 hours later? 2.5 milligrams, and so on and so forth. Okay, so I am told that the half-life is 12 hours, and I would like to use it in here because it will give me something. I will be able to determine something.
Will those equations be on there?
Yes, I will give you. Yes, I will give you the model. Yes, they're all the same. But yes, you'll have the model.
That's the same for all half-life problems. Okay.
Yes, but you don't have to memorize it. So I don't know the original. I don't know how much aspirin I took. But I know that in 12 hours, so when this is 12 hours and this is 12, then this is half of the original. What does half of the original mean? If A0 is the original. What do I mean by half of the original?
A's heard about that too.
Exactly. And this is 12 multiplied by 12. Good. So I have an equation right now. I don't have the original, but I know that when t is 12, then the amount is half of what I took originally. So what will you do to this equation first? Of course, I'm asked to find k. I have to determine k. K is my target. So what should I do first to both sides of the equation to make it as easy as possible? Okay, multiply by 2, that's the first thing. 12k. What now?
Divide by.
Exactly. I have to get that A0 out of the way. What do I have on the left? 1. What do I have on the right? Times 212k. What will I do next?
5 by 2.
Good. I'll say 0.5 equals e to 12k. What will I
Natural log of both sides.
apply? Natural log to both sides. The left-hand side will be natural log 0.5. What will be the right-hand side?
12k.
Yes. And what about natural log e?
1.
Excellent. And finally, I get k, which is the growth, in this case, the decay rate for this particular substance, which is aspirin. So I have natural log 0.5 divided by 12. And this has to be a negative number. So I put it in the calculator. Natural log 2 divided by 12. Oh, what did I do? Look at this. What happened? Okay, so I don't see anything, so I can't plug in anything.
There's.
Oh, okay, got it. Okay, sorry. So natural log 0.5 divided by 12. Good. So negative 0.0578. Okay, now the question is, how long? I have to put it back in the model. Now I have the model. I have A of t equals A0, which I still don't know, times e to negative 0.0578 t.
Sorry, the A of 0
Is the initial. We are not told how much we took initially.
But did that turn to 1?
It turned to 1 because we divided both sides by it. So what happened was, we were told that the half-life is 12 hours. So if I take whatever, in 12 hours, this becomes whatever over 2. So this was initial. This is what what I have in my bloodstream 12 hours later. So when t is 12 hours, this is A over 2. Then we multiply both sides by 2. We divided both sides by A0 because A0 is unknown and it's a positive quantity, and it will simplify the equation. Otherwise, I cannot solve for k. Then we divided both sides by 2 again, and then we applied natural log, and we got k. Once we got k, we put it back in the model. And now I can answer the question. And the question is this. How long will it take? Again, I'm asked to find t. For the aspirin to decay to 70% of the original. What is the original? How do we call it? If we don't have it, what is it? A0, yes, or A naught, good. What is the operation every time I talk about 70% of a quantity? What operation do I have to perform? So 0.7 times A0. Of is always multiplication. Multiplication. Perfect. So I'm asked now, look at the model and tell me what to do. How many t was in hours, of course. So how many hours will pass till the aspirin in my bloodstream goes from A0 to 70% of A0. It drops from 100% to 70% of A0. How long will it take? Is it less than 12 hours?
Yes.
Yes, because in 12 hours we'll go from 100% to 50%, and this is 70%. So it has to be less than 12 hours. So how do I put this information in the model? What is the left-hand side? This side. Right. What do I replace it by? Exactly. 0.7 times A0 equals A0 times e to negative 0.578 t. Excellent. It's exactly the same procedure, but here I had 0.5. Now I have 0.7. 70%. The exact same procedure. What will I do next? Yes, A0 is an original quantity we don't even care about. We don't have it, and we cannot determine it. So then the equation is 0.7 equals e to negative 0.0578t. Like before,
natural log.
Natural log, I apply natural log to both sides, so I have natural log 0.7 equals negative 0.0578 t. What type of number you expect? It's time,
Positive.
of course. So natural log 0.7 over negative 0.0578. So natural log 0.7 divided by, in parentheses, negative 0.0578. Or I could have recalled the previous answer. So as expected, it has to be less than 12 hours. So roughly 6.2 hours. These are all problems that you will see from chapter 4. Section 4.5, I meant to say. Let's go back now to 4.4 and look at some more equations. Please choose anything. Okay.
I accidentally used the number from the other problem on top of it. I figured.
Okay, just any problem. Let's look at anything you like from 1 through 92. They start on page 489. Okay, I will start with 14 and then you choose the next one. 5 raised to 2 minus x equals 1 divided by 125. It is true that we now, since we know the method of applying a log to both sides, we can always do that. However, it is easier if, in this particular situation, you present both sides with the same base, because they can be presented with the same base. So the left-hand side is 5 raised to 2 minus x. What will you write for 1 over 125?
125 to negative 1 to start out.
Okay, so 125 to negative 1. Very good. 5 raised to negative 3. This is too easy of an equation to mess with applying log to it. There is no need. So now remember, we are not simplifying 5s. We are not dividing by log or applying log. We are not erasing the base. Here's how we think. Two numbers are equal, and they have the same base. What has to happen with their exponents or to their exponents? They have to equal each other. 2 minus x must equal negative 3. Of course, I'll subtract 2, and I will divide by negative 1. And you can always go back and plug it in. However, if we move on to an equation like 28, 19 to x equals 143. I can't present both sides with the same base. I won't even try. And I do have to apply a mechanism which brings the power down as a factor. And it doesn't matter, since this is not e, it doesn't matter which, if this were e, I would have applied natural log. If this were 10, I would have applied common log. But here it doesn't matter. One or the other that you have in the calculator. So let's apply log this time. Common log, it doesn't matter which one. The answer will be unique. So I have x log 19 equals log 143, and now I get x, which is log 143 over log 19. Careful, this is not log of 143 over 19. So the top, log 143, close the parenthesis, and divide by log 19, close the parenthesis, enter. I get 1.685 something something, approximately 1.6855. How do I check my answer? I'm not sure that this is correct. How will I check? I will raise 19 power caret in parentheses the previous answer and close the parenthesis. When I click enter or click on enter, what should I get? I have to get 143. There is no way I would have determined this by hand. It's impossible. I would have never been able to tell you what power we raise 19 to get 143. Not in a million years. Okay. Now, 41, although I don't think it's a difficult problem, I think is cumbersome. It requires a lot of steps. I don't recommend you approximate till the very last step. So I can't present 5 and 3 with the same base, no matter what I do. So I need those powers to come down.
Which one did you do? You didn't do 29, you did 28. Right? I did a lot of stuff and I was like, what?
Sorry. Too late. I would have changed it, but okay. So
can you basically use the natural log pretty much with
in all of them,
for most of them? It's
yes.
just
All exponential
when
equations.
you get to like the 49 to 92.
But if you have a base 10, no. I'm talking about the exponential equations, not the log equations.
Yeah, I know.
Okay.
I'm just saying when you get to the numbers like 49 through.
Yes, we'll do that in a minute.
Okay, I'm sorry.
Please, I'll let you choose. So now we have both sides 5 and 3 cannot be presented with the same base. I highly recommend keep that in mind here because it's easier if you use that just one step. You don't have to apply log. But here I have no choice. It doesn't matter if you apply natural log or you apply common log. It doesn't matter, but it has to be the same on both sides. So which one would you like to apply?
I use natural log.
Oh, that's fine. Natural log. Now, if you make the mistake not to put 2x plus 3 in parentheses, the whole thing collapses. It has to be in parentheses and then multiplied by natural log 5. Like on the other side, x minus 1 must be in parentheses and multiplied by natural log 3. If you omit parentheses, the whole thing is changed completely into something else. So now, one more time, if you remember, I said, do not be afraid of these. They're just numbers, sophisticated numbers, but they're just numbers. So I will distribute them to these two terms. So 2x natural log 5 plus 3 natural log 5 equals x natural log 3 minus natural log 3. So now I notice that these two have x, but the other two don't. Now this is just a linear equation.
You isolate that.
I have to, yes. So I will have to move this next to this and this to the other side.
So it would be what, x plus 4?
So 2x natural log 5 minus x natural log 3 equals negative natural log 5 minus natural log 3. Nothing can be combined. They're not like terms. So what should I do on the left-hand side? Because I still need to solve for x. I'm factoring out x. So what is left in parentheses? And this is final. The right-hand side is negative 3, natural log 5, I mean the top. And the denominator 2 natural log 5 minus natural log 3. Yes, if you want to approximate, you have to approximate if you would like to check. So if you want to approximate this, you have to be very careful with parentheses. So left parenthesis for the top, negative 3 natural log 5 minus natural log 3. Close the parenthesis for the top, divided by parentheses again, 2 natural log 5 and then minus natural log 3. And don't forget to close the parenthesis for everything in the denominator. Negative 2.7954. 2.7954. And yes, if you want to check what I would do in the original problem, I would move this to the other side. I would say this is 5 raised to 2x plus 3 minus 3 raised to x minus 1. In this expression, because I don't want to have two expressions, in this expression, so in y equals, I will put in 5 power in parentheses 2x plus 3 and minus 3 power in parentheses x minus 1. And then I will go to second table like we've done with everything, and I will punch in negative 2. Why does it do that to me? Okay, I'm gonna start from scratch. I'm not sure what happened. I clicked on something. 2x plus 3 outside minus 3 and the power in parentheses x minus 1. Okay, 1 second and table, please. Thank you. So now all I want to plug in is that number, roughly, negative 2.7954. What does this mean? What does this number mean?
That's very close to 0.
Exactly. How do I show the exact 0? I will use the previous entry, the previous answer. So I will have 5 caret in parentheses 2 times the previous answer plus 3 minus 3 caret in parentheses the previous answer minus 1. It's guaranteed now that when I click enter, the answer would be what do you think?
1.
It cannot be 1.
I mean,
Exactly
it would be 5
0.
to the 0.
Exactly,
minus 3 to the
exactly
0.
0. It has to be 0. So what I checked is this. I created this function by moving this side here because I didn't want to have two sides. I didn't want to punch in two different expressions in y1 and y2. So I created this, and when I plugged in this number in here and this same number here, the answer should be 0. And it was. Okay. Now let's look at logarithmic equations, please. Which one did you have in mind, Eric? Which one?
No, the one I was talking about, I actually copied something down from the problem above it.
Okay, in that case, can I choose one? Okay, 76 log base 2 of x minus 3 plus log base 2 of x minus log base 2 of x plus 2 equals 2. I do not consider this problem a trivial problem. Remember when we solve log equations, we must apply one of the two methods that I presented to you. One method is, no matter what I get, I go back and check. Second method is, state the domain. Whichever you think it's easier. For me, because sometimes I forget.
It's more of a habit, I think, when you do it.
Exactly.
And you don't forget to.
I think so. Sometimes I forget. Sometimes I get lazy, I guess. I don't know. But I forget sometimes to go back and check. So I know that log can be applied only to positive numbers. Therefore, x minus 3 must be positive. Also x must be positive. And also x plus 2 must be positive. The first inequality means x greater than 3. The second inequality is x greater than 0. And the last one is x greater than -2.
So we have to use x should is greater than 3.
Exactly. So -2 to
Combined
infinity, 0 to infinity, 3 to infinity. And I have to choose where they all overlap. One more time. -2 to infinity, 0 to infinity, 3 to infinity.
3 to infinity.
So is that clear why it's 3 to infinity? Okay, let me show you. So on the real line, oops, I have 3 to infinity, which is this. I have 0 to infinity, which is this. And I have -2 to infinity, which is this. I have to choose where I see all three colors, meaning all three logs have to exist. Where do I see all three colors? Is that clear why it's 3 to infinity? So if the solution is not a number strictly greater than 3, I will conclude that the equation has no solutions. Okay, now I'm ready to condense it. So please tell me how to condense it. Now we know that if a log has minus in front, its quantity goes where? Bottom. If a log has plus in front, its quantity goes where? Good. So can you please in one step condense this for me?
I'm sorry, my number. Okay, 76.
1x times x minus 3 over
Excellent. Now I know that this is equivalent to a very, very easy exponential equation. Where do I start?
2 squared equals
Exactly. 2 squared equals this. X squared minus 3x. I'll distribute the top over x plus 2. I'll change 2 squared into 4, or 4 over 1, and x squared minus 3x over x plus 2. And this tells me, this is a hint that tells me what to do next.
Cross multiply.
Yes, I strongly recommend it. So what will you write?
4x plus 8 equals x squared minus 3x.
Now, look what happened. This is tremendous, the amount of work. And we're going from step to step to step to step. Look what we started with. We started with a log equation. Then we stated domain to find where the solution should be. Then we changed all this into this equation. Then we into a log equation, simple log equation. It's not that simple though. So then from the log, I changed it into an exponential. From an exponential, I changed it into a proportion. From a proportion, I changed it into a quadratic equation. A lot of work. And now I have to think, hey, how do I solve a quadratic equation? Well, I have to have everything on one side. So I subtract 4x and I subtract 8. And yes, I'm hoping that it's factorable, so I speed it up.
That's 8.
X minus 8, x plus 1, so x equals
8 and -1, and you go back and check.
Exactly, and after all this work, I really don't want to go back and check. And I don't really have to. I can only check against this. And I'll say, no way. And I'll say, this is it. I made my life easier. I don't have to go back to the original problem. However, you may say, no, I don't want this. I promise I'm going to check. That's fine.
No, I didn't even see it.
No, I wasn't talking to you. I was talking in general. No. I'm fine, but you have to choose one or the other. Can we go further backwards? Or we want more logarithmic equations? One more or not? Okay, good. So I'm going backwards now. 4.3, expanding and condensing. Since we've done condensing, let's do one with expanding. Is that okay? Okay. So let's say 37. On page 477. So we have natural log x cubed, the square root of x squared plus 1. Everything divided by x plus 1 to the 4th. Now, if you want to use what we just discussed in the previous example, You could change this into 3 logs in one step. You don't have to. You don't have to do it in one step. Would you like to do it in one step?
You could do
So it's going to be natural log x cubed, but plus natural log the square root, but minus what?
4 natural log.
Yes, let's do it in 2 steps. That part, let's do that in 2 parts because I did not use the power rule here and the power rule here. Excellent. So now if I want to put it back, can I put it back? These 2 have to come from the top, and this one has to come from the denominator. Are we okay with this?
Yes.
And yes, the final step is to bring the power down. All 3 have a power. What is the power on the first one?
3,
What is the power on the second one?
1/2.
Indeed. And what is the power on the last one?
4.
Do you think we need more? What about let's review also the change of base formula. If I'm asked to find log base 3 of 2, I have no idea what power I raised 3 to get to. I have no idea.
You would do log 2 over log 3.
Or natural log 2 over natural log 3, one or the other. We put in the calculator, you choose, doesn't matter which one. So natural log 2 divided by, oh, really? Divided by natural log 3. And that is roughly 0.6309. How do I check? I raise 3 to the previous answer, and I press enter. It better be 2. Going back, in 4.2 and 4.1 we have graphs of logarithmic and exponential functions, and I would like to discuss the domain. You will have a problem like this, no secret there. I'm going to ask you to find the domain of natural log of x plus 1 over x minus 3 as an example. So find domain. What do I have to write? We already found domain on all these. I found the domain for this function by writing x minus 3 positive. I found the domain of this function by writing x positive. I found the domain of this function by writing x plus 2 positive. Before I forget, you have to state a domain on the raw equation if you want to use this method. You cannot condense it and try to find the domain on this. It will be a different domain. Okay? So please, if you use this method, you cannot do anything to the equation before you find the common domain, which will be this. Okay, so what do I have to write and solve? X plus 1 over x minus 3 has to be strictly greater than 0. Log is applied to this. How do I solve this inequality? And this comes from the previous test.
Oh, you use
If you want to use the chart, use the chart. If you want to use the method in the book, use the method in the book, whatever you do. Which numbers go in the chart? -1 and? Yes. So 0 and 0, undefined and 0. Both are positive, have positive slope. You don't have to plug in anything. Negative over negative is positive. Positive over negative is negative. Positive over positive is positive. I have the domain. Remember, I need this. Is it okay? What is the domain?
it's greater than 0 would be,
Notice that this does not have the equal symbol. I cannot include -1 because it does not have the equal symbol, and of course I cannot include 3 because it's undefined. Good? What if I ask a problem like this? Graph using transformations. F of x equals -2 to x plus 1 plus 2. And find x and y intercepts. Algebraically. I would like to start with that, to find the x and y intercepts first. How do I find the x-intercept for any function? Yes, I said y equal to 0. -2 raised to x plus 1 plus 2 equals 0. What will be my next step?
Subtract 2.
Of course. So -2 to x plus 1 equals -2. What is the next mandatory step?
Log of the natural.
I can never apply log to a negative number. It's not cleaned up yet. I have one more step to clean it up.
Multiply by -1.
Exactly. So 2 to x plus 1 equals 2. I don't need log. Two numbers are equal and they have the same base. Yes. So x plus 1 must be?
0.
No, this is not power 0. Power 0 will make it 1, right? 1. So then x is indeed 0. So 0, 0 is the x and the y-intercept as well. Okay? What is the base function here?
2 to the x.
Excellent. What is the first step that we have to perform?
You have to move it left.
Yes.
1 unit.
2 to x plus 1, left 1. Next step. After I'm done with this,
You would have to vertically
reflect with respect to the x-axis. So I'm done with this. Now what?
Plus 2.
Very good. No,
That count up to.
up to. Perfect. So how do I graph 2 to the x? What type of function is it? I know it's exponential, but also is it increasing on all its domain? Is it decreasing? How do I graph it and where it crosses? The base greater than 1 is always increasing. And it crosses here at 0, 1. So this is y equals 2 to the x. Then you told me to move it to the left 1. So I will move this point here. Where? What is this?
-1.
Excellent. So here's the graph. This is the graph of of 2 to x plus 1. Then you told me to do what?
Reflected.
You told me to reflect it with respect to
The x-axis.
where will this point move? So I have some sort of,
to -1.
yes, right here. Good. So this is -2 to x plus 1. And then you told me, and I know this is a horizontal asymptote, and then you told me to move this graph where?
Up 1.
Up to. I have to move the horizontal asymptote first. The initial horizontal asymptote was y equals 0. Where will I move it now? Very good. This is 1 and this is 2. So now this is y equals 2. And I know because I just determined this algebraically, that the function will go through this point. And where does this point move now? Right here. So this, you don't have to do this, it's just there are so many different graphs in my graph here. So I just want to emphasize this is the final graph. Final. So f of x, -2 to x plus 1 plus 2.
Could you move it down?
Yes.
I have a question about graphing the y equals x or 2 to the x. How do you graph that again? Like, what if it was like y equals 3 to the x? Like, what would you do with that?
Excellent. I will simply have the exact same shape. 3 to the x will be just slightly closer to the y-axis. So it will be something like this. But you will have to cross the y-axis at this point, because when x is 0, y is 1. So all of them, 10 to the x, e to the x, 2 to the x, 3 to the x, all of them will look very similar. And I have to cross the y-axis at 0, 1. Because when x is 0, this is 1. 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 The higher the base, the closer will be to the y-axis. But they all have the same shape. This is never going to be a perfect graph. I'm using transformations to see the shape. I know for sure that this is the horizontal asymptote. I know for sure it passes through these 2 points because I moved this point from here, and then up to. And this must be the shape. If it's a little bit closer to the y-axis or further away from the y-axis, is not important. All I care about is the shape.
So you're not looking to label points.
If you want to, you can, but I don't want you to work too hard on it. If it says transformations, that's all I care about. The x and y intercepts, asymptotes if there are any, and the shape. Good. I think we're done with this chapter, so let's go back and please tell me. We had quizzes from everything in chapter 3. What I'm going to ask from chapter 3 is a quadratic function with, please remember the vertex formula. Every time you're asked to find max or min, you will be using the vertex formula, right? There is only one function that has vertex, which is quadratic. My pre-calculus class graphed on their last test a polynomial function which was like this. They graphed vertical asymptotes. Exactly. That's my point. A polynomial function does not have any asymptotes. Does not have horizontal asymptotes, does not have slant asymptotes, does not have vertical asymptotes, only rational ones, right? So please remember that. So I will ask you to graph a quadratic function and solve a word problem with a quadratic function. I will ask you to graph a polynomial function, degree 3 or 4, not more. If you know 3 and 4, then you know any degree. Please remember the multiplicities and what they do. Multiplicity 2, 4, 6 is a turn. Multiplicity 1, 3, 5 is a cross, but depending what type of cross. The end behavior for even degree. For even degree is either this or this. For odd degree is this or this. A rational function, only type 1 or type 2. I will put to choose from a slant asymptote to choose from as an extra credit. You don't have to choose it if you don't want to. It's not going to be a difficult problem, and you can get easy 10 points. And that will be an extra credit to choose from. Please remember the problem we looked at, problem 101 on page 408, the one with the sugar. We take something with sugar, and then it levels off. I would like you to be able to determine the horizontal asymptote here without even looking at the graph. What is the horizontal asymptote of this graph? It's same degree over same degree. What will be the horizontal asymptote for same degree over same?
6.5.
6.5, exactly. So that will be the horizontal asymptote, 6.5. Okay, and a graph, I'm sorry, not a graph, but of the rational, the 3.6 polynomial and rational inequalities. We already had one. See, actually, we discussed this in this chapter, in chapter 3, not the previous test. I did previous test with my pre-calculus class, not with you. It's difficult when a little bit difficult when I teach 141 and pre-calculus at the same time because they overlap a lot. Okay, so this is what we studied in 3.6. What would you like me to do? Quadratic, word problem, polynomial function, rational function, and an inequality. Yes?
I just have, we need to know the formula for like compounding interest.
No, I will give it. I will give you the formulas. No need. So from these 5, I have 5 minutes. I'd like to do one problem. Any type of problem from these 5.
Rational.
Graph of a rational function. Very good. Type 1, type 2. We don't. I don't know if I can in 5 minutes, but I'll try. Would you like to choose, or I get to choose?
Type 2.
Type 2. Okay. Type 2 on page 407. 60 is type 2. 60 on 407. F of x equals 4x divided by x squared minus 1. Please review and redo all quiz problems with solutions and homework problems. Okay? Please. Okay. So I know the domain of this function because when I factor the denominator, I get x plus 1 times x minus 1. So the domain must be anything but -1 and 1. I will list what I want you to determine so that it will be mentioned. So please present such and such and such. So since these two factors do not go away ever, then I know that x equals -1 is a vertical asymptote and x equals 1 is a vertical asymptote. I know that these are infinities. However, I don't know their sign. And I will be using numbers left and right of -1 and +1, like -1.1, -0.9, 0.9, and 1.1. You can plug this function in and punch it in the graphing calculator. I think it's too easy, in my opinion. -1.1, the top is negative. Negative here is negative. Negative here with negative, yes, negative. So 3 negatives. With -0.9, this becomes positive. The numerator is still negative and this is still negative, so that's why it's positive. With 0.9, the top is positive, this is negative, this is positive, so it's negative. And with 1.1, everything is positive. It's type 2, so then this must be the horizontal asymptote. It goes to 0. And when I plug in 0, I get 0. That's all I need. I don't want you to work too hard on this. The only thing that I have to mention is that the function is odd. So when you plug in -x, this changes and it changes the whole function. You will get negative f of x. So it's an odd function. So you may have to make sure that it's symmetric with respect to the origin. One more time. When I plug it in here, it does not change. But when I plug it in here, it changes. So I will have -4x over x squared minus 1, which is the same with negative f of x. So when I graph a function with asymptotes, I have to start with the asymptotes. That's a must. So this is an overkill. It's already there. Then -1 and +1. And 0, 0. I look at my chart, and the chart tells me everything. From approaching 0 to approaching -infinity. From approaching 0 to approaching -infinity. From approaching infinity, cross at 0, 0, and go down to -infinity. No problem. And from positive infinity approaching 0. And this is f of x. 4x over x squared minus 1. And it is symmetric with respect to the origin. So these two, and then these two. So these functions will not be difficult, and I don't want you to spend a lot of time to find a lot of points here, because that will take it too much. Take too much time of your test. I will not invent anything. You'll have the same problems you've seen before with minor changes. Some of the problems that I like to put on the test